Yes, it's not yet. Hi, Peter.
Okay, let's start with this session. Thank you for coming. My name is Jordi Escriu. I'm working for the Institut Cartogràfic and Geològic de Catalunya in the regional SDA unit. And I am chairing this session on network services. I think it's a subject that is crucial for the current stage of INSPIRE implementation, so I'm sure that we will have some good examples and experiences about that. The program foresees 6 speakers, but one of the speakers is missing, is Agnieszka. So we have a bit more time for presentations. We can devote 18 minutes for each speaker, including questions. So I ask the speakers to deliver their presentation more or less in 15 minutes. So, and if you agree with that, we can keep the questions at the end. So some of the questions may have common, and we can discuss with all the presenters. So the first speaker is Dominique Laurent. He's working in Asian France, and he has actively participated in INSPIRE development as a facilitator of several thematic working groups, and also he's currently chairing the Eurogeographics INSPIRE game. So he's presenting the use of the SLD standard by the ELF project.
So,
thank you.
Good afternoon, everyone. My title, there are 2 acronyms, so of course in my presentation one of the first objectives will be to explain the meaning of this acronym. So to explain what is ELF and what are the ELF view products, the main tool, the SLD standard, what is it, how does it look like, and then which lessons we have learned by using these standards to make the ELF view product, regarding the design of portrayal rules, regarding the creation of SLD files, regarding the implementation, the use of SLD, and a general conclusion. So, ELF view product. Before speaking about the products, maybe some words about ELF. I think that most of you have already heard a lot about this acronym and this project, but for those who don't have yet, what is ELF? ELF stands for European Location Framework. It's a European project with 3.5 years from March 2013 to October 2016. We have around, my slide is not so updated. We had around 3 partners at the beginning, but now we have had a call for newcomers, so we are now around 40 partners, mainly national mapping agencies and Eurogeographics, and technology providers, universities, application developers, private market. The project is co-funded by European Commission and the consortium partners, 50-50, as most of European projects. And the main objective is to implement InSpy regarding the interoperability component and the download services. It's to offer single access point to these harmonized data and services from national mapping and cadastral agencies. And it's make use of InSpy data and services through basic applications such as view and search services and about business application. But in my presentation today, I will talk only about view services. So you have in the map the list of partners of data providers. They are the current partners of ELF, but the ambition of ELF is to cover whole Europe. It's not just a project, it should be a sustainable platform. So our ambition is to get European coverage. So let's now present what are our view products. So first product, we are going at the an overview about Europe from administrative point of view. So it's a pyramid of digital images at various levels of zoom, from 40 million, you see whole Europe, and to 140,000, you can see the municipalities. And it's done using the data from Euroboundary map, and so using SIM administrative unit of InSpy. And at the moment, it's still a web map service, but we are thinking about transforming it into a web map tile service to get better performance. So the idea is really to have this overview of Europe from administrative point of view, from countries to municipalities. Then we go deeper into detail, and we have the topographic base map. So the topographic base map is also a pyramid of digital images at various levels of zoom. The idea is, once again, to have the 40 million scale, so we can see whole Europe, and we go up to 2000, so we can see the streets with their name. So we have really a wide range of level of zoom. We are using InSpy-based data from various SIM, mainly administrative unit, transport network, hydrography, land cover, building, geographical name, and elevation. And the service is a web map tile service that is harvesting the national web map services. So it means that there is tiling and catching done centrally to ensure good performance. And then we have at very detailed level the cadastral index map. So the themes that are considered as cadastral parcels, administrative units, addresses, and buildings. The principle is a little bit different. We have a cascading web map service to view the territory. And in addition, we have something else that is not mandatory by InSpy. We have the get info feature, so you can see the attribute of the cadastral parcel or the features. And as we used InSpy data, of course, we can see these attributes in an harmonized way with the same attributes named everywhere in Europe. So if we have some overview about this ELF view product, you can see that we have different source data. For the administrative base map, we have the European product. For the topographic base map, we have a mix of European products for the small scale and of national data for the large scale. And on cadastral index map, we have only national data, we have only large-scale data. We have common portrayal rules that are designed in a centralized point of view, and what is done at national level or at centralized level, of course, depends on the product. For the administrative base map, we do everything at centralized, and going to more detailed level of detail, we use also national data, national services, and the cadastral index map is almost fully local, fully decentralized. We just have a cascading service to offer a single access point. So we have really different types of architecture, way of organize the work. So the SLD standard, how does it look like? So first, what means SLD? It means style layer description. It's an OGC standard to document the portrayal rules, the way you are going to do mapping from vector data. So it's an extension of the web map service, and it uses other standards that has a symbology encoding, and the symbology encoding itself use filter encoding. So there is some kind of also cascading standards, if I can say this. In practice, how does it look? As many things in ISO and OGC, it looks like an XML file. If we look a little more into details, so the SLD, how is it organized? It provides the order to display the layers. The first layer you put in your XML file, it's the first layer that will be displayed in the service. And then, for each layer, you get the layer name. If necessary, you get a query, a selection. For instance, if the portrayal rule is not the same for all the feature within a feature type. Okay, so you can see, for instance, I think my animation is not so good. Here it's physical waters, the layer name. The scale range, there is some discrepancy. In fact, it's a little upper. So you have a minimum and maximum scale. And then you have the symbol to be used. So here it's something very simple. It's just filling the polygon with a unique color. So now let's go to the lessons we have learned. The first point is about designing portrayal rules. How easy is it to be done? So the first issue occurs with the filter encoding. Some InSpy models, mainly in transport network, they include some modeling patterns that cannot be handled by SLD. For instance, there are feature types that have no direct geometry. The road, the railway line, they do not have direct geometry. They are just composed of road links. So it cannot really be handled by the SLD. And we have also this issue about linear referencing. The properties of the transport network, they are not modeled as attributes directly attached to the road link, but they are modeled as feature types attached by linear referencing to the road link. And is it something that is complex and that cannot be handled by SLD, or at least we didn't find the way to do so. So the solution we chose, it was to make the base map model. So we used really the InSpy application schema starting point. It gave us the InSpy terminology, and we just selected the attributes that are useful for mapping and to put them in a more flattened way, for instance, for transport, to put the attribute on the road link or on the road and not by linear referencing. So one of the lessons is that InSpy data had to be simplified for mapping purposes, at least for transport network. We have simplified for all, but for transport network, it was really necessary. I think we could not have managed without this simplification. Then, regarding the design portrayal rules, what about symbols? For those who have already used SLD, SLD is known to be rather simple and not dealing with complex symbology. For us, it was not such an issue because our purpose was to design a base map, so something simple. So we have really simple symbols that can be, SLD is enough for us. You can see some examples on the slide. There was an exception, it was for the point. We would have liked access to library, for instance, for specific buildings. It might be better than just simple symbols, but as we didn't have this library, we just gave up and we just represent all buildings in the same way. And for the other point features, we decided to use the simple symbols offered by SLD, such as circles, triangles, these kind of things. Regarding the labels, the text we put on the map. So the filter encoding enables selection rules about the labels to be displayed in a given scale range, but importance of nameplace is often missing in source data, or it's not accurate enough to allow relevant a selection that is enough for mapping. So, for instance, we decided to use Euro-regional map for populated place because we had this attribute population in Euro-regional map, whereas we didn't have it yet on national data. And generally, with the selection rules, there are always areas where anyway there are too many labels on the map. So, in fact, there are the web map servers that make some selection, some random selection within the priority group you decide. So regarding these labels, normally the standard offers a way to define how to locate the labels, for instance, geographical names, road numbers, but in practice, web map servers may offer more advanced functionality. So the solution we adopted was we didn't really define the location, we let it up to the NMCA, use the functionality of your web map server in the best way you can do it, because it's done better by the implementation by the web map server than by the standard. Now, there is I will say, the very practical issue about how to create SLD, how to make the XML file, which tool can we use. So in fact, we had 3 different experiences, the administrative base map, the topographic base map, the cadastral index map. We had 3 different partners making the design, IGN France for the administrative base map, Kartverket for the topographic base map, and the University of Delft for the cadastral index map. We use different tools. We tried to use GIS, such as Quantum GIS or Web Map Server, GeoServer. And in all the 3 cases, some part of the work was done with the software, but some part of the work had to be done manually. In the L project, there is also a tool that is called the SLD editor, and that might help us in future because it allows to edit an existing portrayal rule, an existing SLD. But to make the initial one, it was not usable. It may serve in future to improve our legend. So implementing the SLDs, we use different technologies, for instance, using map server, using GeoServer, using S3GI ArcGIS, using Intergraph, and Degree is also possible, but I think it was not used for view services. So in a way, it's a positive thing. So yes, this standard could be used with different implementation solutions. The thing that was not so positive is that sometimes the standard required some adaptation to be really used by various implementation. So some conclusion. On the positive side, a lot of things, because you can see this SLD has been used by all health data providers, and I will say also by different designers. So really, without this standard, we could not have done anything. It has really supplied a common language to document the portrayal rules in a decentralized way, in this decentralized architecture. This SLD has been used with some adaptation by different technologies, by the web map server with different implementation of web map server. We have used also this standard. In fact, our design of portrayal rules was some kind of agile development, so we have changed the version sometimes several times rather quickly because we were not totally satisfied with the first one, and the national mapping agencies could work with the different version without complaining too much. So it was nice also to have the standard working with various versions. What is nice also is that we have used this SLD for web map server, but with this idea of having minimum scale and maximum scale, it can be used then to make the web map tile service. We can use the images of the web map server to make the tiles at various levels of zooms. So it has really worked in, I will say, in various conditions. What are on the negative side, the conclusion, it's about providing the XML SLD. There are some tools, but no one is perfect and allows good export of portrayal rules, and there is still some remaining work to be done manually. That is cause of extra work, errors, and so on. And I think it's not typical to SLD, but label processing is really an issue. I think it's an issue in traditional cartography with paper maps, but probably even more when the objective is to make automatic cartography on the web. So I think there are improvements that can come from better data, to have more accurate selection, from better standard, from better implementation of standard. But really the labels, processing of label was the main issue. And I think that's it.
Thank you very much, Dominique. So, our next speaker is Peter Baumann. He's a professor at the Jacobs University in Bremen and also working in Radesman company in Germany. And he is leading and actively participating in the OGC groups for the standardization of WCS services. He's presenting the integrating Inspire into a single seamless information space.
Okay. Oh, very good. So, and hooray. May it begin. Hello, everybody, and thanks for having me here. So, I'm going to talk about the coverage part specifically, maybe the big data in the geo world, and about how to integrate services into a single seamless information space. That was an aspect that has just been addressed in the previous talk, and federated strictly through open standards. So when we talk about coverages, as I said, we have the big problem of big data unifying all of that into a single common service. So we want to have everything in a server, be it sensor data, be it simulation output or that kind of things. Whenever it fits into that scheme, we want to look at it. We want to maybe mix in other data, and at some time, maybe a machine is talking to my machine. We have machine-to-machine communication, and that means it really needs to have a really exact semantics so that those two can work together without any helping hands. That is a particular challenge that we want to address with standardization. Actually, in OGC, where I come from, I'm the editor of the WCS and the coverage specification and engaged in several working groups. We try to build a mosaic that gives a big picture where, for example, sensor observation service allows us to capture and grab all the data and to homogenize them so that they can be served as coverages through the web something services, like, for example, the web coverage service. Fortunately, we are experiencing quite some convergence here. So we have the OGC stuff, the coverage implementation schema as the data definition, and the web coverage service and web coverage processing service as the service model. By the way, with Rasterman being the reference implementation, and that is being adopted now by ISO as well. So in TC211, activity has started that the coverage implementation schema is to become 19123-2, accompanied by what we know already, the 19123, which, however, is going to be reworked, modernized, and will become 19123-1. That's also something that keeps us busy currently. By the way, after that is done, we will address WCS, which ISO also wants to adopt as an ISO standard. By the way, just on the side, in ISO there's another activity. SQL is currently being extended with multidimensional arrays. So in future, we will be able to query that kind of data, gridded data, directly in the SQL database. That leads to a first level of integration. Our tabular metadata plus the gridded data in one and the same ecosystem. However, coming back to GeoWorld, as we all know, Inspire is currently adopting WCS as coverage download service, by the way, again, with Rasterman as reference implementation. Okay, so these pieces are going to fit together, and that's a great thing because it will allow us that vanilla implementations can work for Inspire. We don't need Inspire-specific implementations. Okay, so I talked about these concepts. Let me briefly present them. Let me take that opportunity. So we have a coverage which actually can be seen as some spatial-temporal grid or point cloud or general mesh. That's the overarching paradigm. Typically today we concentrate on grids and point clouds. And grids themselves can be regular, they can be irregular. So you see several kinds of such things here depicted. And that includes in the new coverage implementation schema also GML 3.3 and sensor ML. This is interesting because sensor models now can flow directly from the sensor into a coverage service without loss of information. That's, again, closing an important gap. The internal structuring now can do the classic thing that we all know. There is a description of where the pixels sit, and then there are the pixel values. That's the domain range representation, but also time series. So geometry value pair lists, like a zipped representation is possible, or, and many people are asking for that, partitions, tiling. The whole thing can be shipped in any suitable format, like binary formats, TIFF, netcdf, and you can have multiple files comprising one coverage that can be packaged and sent out. By the way, formats. So if you prefer angles, then maybe you want to go for the GML representation. If you prefer curly braces, then maybe JSON is your kind of thing. So that's what a coverage would look like there. Please look carefully. I will rehearse afterwards. And if you like to think in triples, then maybe RDF is your kind of thing. All the same representation, so everything is coherent and goes into the different service worlds, like ontologies in RDF and directly into the browser in JSON. So that's the data structure. How do we serve that? Well, with the web coverage service, for example, but I hasten to say that's not the only thing. You can serve it via WFS and even an SOS as well. That's possible. It's just that the web coverage service offers coverage-oriented functionality. So actually this is a nicely modular architecture that implements OGC's modular specification model, saying we have a core. This is the mandatory functionality, and that is really simple. Give me that coverage or give me part of it. So trimming, like a cutout or slicing, reducing dimensionality, like extract a slice from a time series stack or go through and give me a time series analysis. That all can be done here, and that's it. Oh, I forgot format encoding, but that is the core, nothing else. Extensions are optional facets which add further functionality up to analytics to ad hoc analytics. Rasterman is the tool that implements all WCS extensions. And actually, generally, for WCS core and selected extensions, we find a large and growing basis. So you find all the famous names here in open source world. You also find proprietary systems. So actually, we can now get independent from particular implementations. We know it will work with this and that WCS because we have a conformance test suite that allows us to test conformance down to the level of single pixels. So we know that they do the right thing. I want to present you one particular implementation, the one with a strange name, Rasterman, standing for Raster Data Manager, which essentially is an array database that actually it extends SQL with multidimensional arrays, and underneath it has a scalable parallel distributed processing engine. You can download that, rasterman.org, source packages up to pre-confectioned virtual machines. That is actually in operational use. The European Space Agency, for example, hosts a Rasterman installation with 145 terabytes and growing. And I will show you a few more in a minute. And we are proud to have received quite some innovation awards. This is a few of them. So winner of the Big Data Challenge and the Copernicus Master Competition, and US magazine CIO Review has picked us into the 100 most promising big data solutions. By the way, the only array engine. The architecture is like that. Geo-services via OGC interfaces underneath an array engine that can store data in the database or in the file system, or we can work on any pre-existing archive. So you don't need to copy data necessarily. The service will always be the same, the queries. But I hasten to say, I'm talking about SQL and query languages. For sure, this is not an end-user interface. People should stay in their ecosystem. And via the standards, this is possible. They can use something like Map Server, Leaflet, NASA Whirlwind, which we like to use as a really nice front end, or come in via Python notebooks. All that is fine. And that gets me to Earth Server, an intercontinental initiative where actually agile analytics on data cubes is the topic. 3-dimensional satellite image time series and 4-dimensional climate data set. Rigorous standards are the interfaces between client and server. Nothing that deviates from the standards. On the server side, we find Rasterman from the EU if you want, and NASA Whirlwind from the US on the client side. And as I said, hundreds of terabytes we manage already, and the next step within a couple of months will be crossing the petabyte frontier. The goal, and that actually gets me now closer to the title, is a global federation, so that these data cubes can be mixed and matched at any time, regardless of where they sit. And now follow me into a live experiment. Let's see what happens to show you exactly that. So, now we are connected, I would hope, to the internet. And we have a query here that determines heavy rainfall risk areas. We send that to the European Center for Medium Range Weather Forecast that has precipitation data, but they don't have satellite data. So ECMWF sends a subquery to NCI Australia that happens to have Landsat 8 data, and that is merged together so that we see the result here conveniently in NASA Whirlwind. So actually, ECMWF has automatically spawned a subquery. We are not aware of that. We don't see that as users. You can send the same query, by the way, directly to NCI. And now NCI will have the problem that they don't have the climate data. So they, in turn, will send a sub-request for ECMWF, which will process the request, send the intermediate result back for merging, and then it comes to us, and let's hope it's the same result as before. Yeah, looks like, more or less. So, this is the federation aspect. Actually, you retain sovereignty on your data. You keep your data on your server. All you do is you join a federation, and suddenly you become part of something bigger, and that means all your users get all the data in the federation. What you don't have, you will fetch dynamically, and only that small part you need. No big data transport. We want to avoid that. And how fast can that be? This was slowed down because I cannot talk that fast. If you go into the cloud, here in Amazon Cloud, we have a data cube that hosts 1 terabyte altogether. You see a mix. This is not balanced in any way. We just put it on the 9 Amazon instances. and we query one point. You see how many nodes are engaged, and you see that it takes 100 milliseconds. We query a chart, and a few nodes are involved, and we see that it takes 100 milliseconds. Now we go into the entire data cube and extract the time series, and we get that in 230 milliseconds. So that is the speed at which technology operates today. And this is combined with getting everything together into a federation, and back into my Windows presentation, because that, for concluding, so coverages are a very convenient abstraction. It allows us to do a few things under one common umbrella, which traditionally have been disparate and different and difficult. So we talk in general about spatial temporal sensor data, images, image time series, simulation output, and statistics data that we can model as coverages today. WCS and WCPS actually can act as download, what we have seen, but also for visualization. You can do diagrams, you can do pictures, and you can feed a virtual globe with it, as we have seen. And of course, analytics. Rasterman I've shown as one implementation of WCS that stands out. It's flexible through its query language, supports open standards, it's mature, has large-scale deployments. And yes, if you want, visit us at rasterman.org, or just have a chat over there. We have a booth over there, and we can have a discussion about several more aspects. For now, thanks a lot for bearing with me. Thank you.
Thank you, Peter. Our next speaker is Torsten Friebe from the Ladlong company in Germany, who is mostly the implementer, the developer of Degree.
Yes. Cool. You maybe are here, or that's one. The one. Yes. No. Okay.
Perfect. Okay, so I take this microphone. These are too small for me. Okay, hello. I will talk about Degree Enterprise and our offering a comprehensive service package for Inspire. So my name is Torsten Friebe. Thanks, Jordi, for introducing me. I'm at Ladlong, and I'm also a member of the open source project Degree in the TMC Technical Management Committee. And together with our partners from GRID and Andreas Rose, who's co-author of that slides and our offering, who's sitting in the room. And if you do have a chance to talk to him before he's sitting off to the airport this afternoon, you know his face now. Okay, so let's start with our motivation, why we decided to make an offering which we call Degree Enterprise. The reason is that when we talk about Inspire, at least I heard this quite often during the conference, this conference and during the last years, Inspire seems to be complex. And it requires a lot of knowledge, technical knowledge and experience to get Inspire working. So when Inspire is quite complex and our customers do say, well, we don't want to take care about all these aspects of Inspire, they do have a problem we would like to solve. And because our customers consider themselves not as their core business to deliver Inspire services and data. They only want to get rid of that activity. And here we jump in as a company, as an offering. We want to get that job done. This is our full service offering I would like to present. So just imagine you would be a data provider. Is there a data provider in the room? Cool. Okay, just imagine you would sit us in a meeting room and we talk about Inspire. So we talk about a lot of the, Inspire and the technical stuff, but at the end you say, well, no, that's not my job. And we say, okay, it's our job. And we say, and that was the phrase we coined during that meeting is, just give the data and we will do the rest. So what is the rest we are doing? That's interesting to know because we say it's easy. And then we left the meeting room and said, okay, so what we do have to offer? What will you would get if you would have been in that meeting room? So what is our service offering? We say it starts really from the beginning. It's starting with the ETL part. So you've got data. We have to transform it. We have to load it into a database. We have to load it into a file system. We just heard that there are terabytes or even gigabytes of data available, which has to be loaded into databases or file systems. We will take care of that. If you have data then in your database or on the file system, you want to serve that data via Inspire compliant services. And that is our job as well. We will take care of that as well. If you do have a running service, which not easy, but we can accomplish that, you have to comply to the Inspire server level agreements as well. So we will take care of that as well. So in terms of response time capacity, that it will be available 24 hours a day and 365 days within a year. After we left the meeting room, we asked ourselves, so what do we get? We want to get money for it. That's a surprise. We want to get money for our services we do provide. That is a monthly fee you pay us that we take care about that activities I just described before. And if you want us to do the transformation of the data, that is depending on what kind of data and what actions are needed to transform that data, we have a specific data transformation fee. So after we left that meeting room and said, okay, we know what we have to deliver, we know hopefully what we do get, how do we do it? And since we use both Grit and Latlon, the Degree open source framework, we stick with Degree. And here's some very important information for all of those users or data providers who already have Degree running. I want to share with you the information that within this week, on Tuesday, I got from OGC the email that Degree has passed OGC compliance for the 7th batch for reference implementation. We do now comply to the WMTS standard 1.0. And as you see, well, we are quite happy to have 7 batches. Every batch is reference implementation. For those who don't know what reference implementation means, it means it has been tested by OGC in the site process. It's publicly available. You can access, you can even get the code. So it's a reference implementation. And for developers, you can have a look on the code. You can see how we did it. And we are, of course, happy if we get contribution from you back, how we can do even better. For you as an Inspire data provider, that means that you have a complete solution, a complete framework, one technology, which provides you a complete Inspire stack. So Degree offers an implementation of the CSW for Discovery Service, View Service, WMS, and WMTS. And I think most of you are using Degree for the WFS 2.0 part, for download services. So everything is there so you can start to use it. And we decided that we stick with Degree and build Degree Enterprise on top of it. On top of it, why do we need something on top of degree? Because degree open source has some limitations. If we want to provide a full service solution, we even need more to do our work. So besides that software is OGC compliant, it needs some quality. And if you are a developer and use degree, or are using degree, you know that there are some open issues at the GitHub where we publicly discuss what are the shortcomings of degree right now. The Degree Enterprise edition will be quality assured. So we will take care that there are no open bugs before we deliver the software and the service. Additionally, we try to address specific needs for data center providers. So if you're running your Inspire services at a data center, we do explicitly address the needs of the people who work in data centers. And we do address the needs of those persons who has maintained and to configure Inspire services which are running not inside their organization, they are running outside of their organization in the IT data center. So far away, no root access to server, no access to even any operating system level operation. So we do have on top of these tools built which allow exactly these activities if degree is running in an IT data center. And around that, we of course provide professional services. So when I talk about these additional tools, I want only to give you a short picture of what we have done. So inside it's still the degree open source project, but on top of it, we built some really nice tools which allow exactly what we need for running degree Inspire services in data centers. So I only will pick a few here for an example. So we have one layer which provides really a comprehensive extension to degree in administrating all the aspects for running degree or Inspire services. So you can upload data via web UI, you can process or start processes via that web UI. That web UI, of course, is secured, so it uses LDAP or Active Directory for authentication. We have to take care of that as well. So you can upload data, you can process it, and you can even then, if data is available, servers are running, monitor the Inspire services which are up and running. One important step here on the business logic level is that Degree Enterprise contains also extension for download service, predefined download services based on atom feeds, which is missing in the open source project, but it's available in Degree Enterprise. And a very important component which we consider as crucial for running Inspire services is a security level, a security layer. Because even if we say data is public, services open source, software, so who's interested in data and software if everything is already public? Someone can get control over your IT system, and that's what we want to protect as well. So no one is hijacking your IT. And perhaps some of you already had a security incident, and all we know is that software has bugs, and there are people out there who try to get control over software and systems. So that's great work. How do you pay, or for what do you pay? So the good news is no license fees. So we don't want to follow the way of other providers, so there's no license fee, but if you want to have that software, you cannot download it from the Degree GitHub website. You have to sign a service contract, a maintenance contract with us, and then you will get access to Degree Enterprise. In Germany, we do have, for the technical part, also a legal part, a legal framework, which is based on, at least in Germany, very well-known contract frameworks, and of course, we are looking forward to have outside of Germany other users which want to use degree enterprise, and then we build a legal framework for that need, of course, as well. And what else are we doing? Why do we decide it again to call it degree enterprise? As you might know, that open source is nice. Things can develop or not. Even that we heard at that conference quite often, that open source project gets stuck at a certain point but didn't continue, then picked up later, but there was no clear roadmap. So one very important part of degree enterprise is also that we do have long-term support, and we do have a roadmap how software will develop, and we will take care of that. And we will try to get in contact, of course, to all the users, try to get the requirements and bring that into a streamlined roadmap for the future, so that our users can work with the degree. Another aspect is, as I already said, data center providers. We see those as our core target group, and they do have special needs. They do have special needs in terms of which IT system is in use, which specific version. And when we talk about degree, it continues, they talk about specific Java versions. So we take care that these IT environments are clearly defined so that we can support the degree enterprise is scalable. And we also support that several user groups can work with the system. So it could be a large organization divided into sub-organizations or sub-organization parts, and they can only access their area. So it supports multi-tenancy. And the security part I already mentioned. So how do we deliver that to data center providers? Here, a technical term, I had to put at least one technical term since I'm a technical person. So we deliver that within Docker. Maybe you already heard, or at least I do recall that there were some presentations where Docker was already mentioned. Everything we package into Docker containers that includes all the open source software, which is well aligned and it's easy to run and to deploy. And it allows us to migrate or to transform degree enterprise into different environments. So if it runs on Docker, you can easily run it on-premise or off-premise, in the cloud, at Amazon or wherever. Okay, so who did it? Yeah, who is responsible? To whom can you talk? The Degree Consortium, currently formed by two German companies. It's Ladlon and Grit. We take care currently of the development of degree enterprise, and we do provide professional services around degree enterprise. But we have an open partnering model, and that partnering model is
2 minutes.
Interesting in terms of that we already have a specific partner for a specific task within degree enterprise. Together with Fujitsu Technology Solutions, a German-based company, we provide highly secured spatial data infrastructures. They do run data centers in Germany, so they are compliant to the German BSE certificate, so they are secured, checked, that they comply to all the legal part, and the data is hosted in Germany as well. And with this partner, we can provide Inspire services which comply to the standards based on the software we are using, and which is also highly secured, which again, I think is very important even for Inspire. If you think, okay, I'm a data provider and I would like to learn more about Degree Enterprise, please come to our website. It's degreeenterprise.com or .de. If you like German or English, please select the domain. And of course, I'm at least here until the end of the conference to answer your questions. And thank you for your attention.
Thank you very much. So our next speaker is now Katharina Schleidt. She's working in DataCop, in a company in Austria, and she has led the development of the Inspire technical guidelines on observation and measurements, and she's currently facilitator of the corresponding thematic cluster.
And the presentation isn't here.
Sorry?
The presentation isn't here.
Yeah.
Where? Get rid of the... Okay, I'm Katharina Schleidt. I'm basically in the process of moving from the Austrian Environment Agency to my own company. This is the last talk I'm doing for the Austrian Environment Agency. And we're going to be giving you some information on the implementation we did for air quality reporting, where we're using both the web feature service for the more spatial data and then a sensor observation service for the actual measurement data. Short background on the AQDE reporting. There's the air quality directive, came out 2008. 2011, we had the implementing provisions done. This requires the yearly reporting of air quality data together with all of the assessment methods. So you need all of the station metadata, how was all of this measured, and it goes down to where the air quality objectives actually reached. It includes up-to-date data, so you've really got the hourly data coming out from all the stations. And the cool bit is that here they already, when they put out the directive 2008, they were smart enough to stipulate the data should be made available by Inspire. So it was a bit of a tight match because Inspire got done basically a few days before the air quality stuff had to be done, but it's done. Quick overview of the reporting flows. These are the main reporting flows for air quality. So you've got information on zones and agglomerations. You've got the assessment regime, which is not really based on, I'm using the Inspire principles for encoding, but is not really, doesn't have any spatial features. Data flow D is all the station metadata. E is the primary data on, so both the validated data and also the real-time data. F is optional right now, there'll be aggregated data, and G is then again more administrative, where the environmental objectives met or not. So how did we implement this? We have UVEDAT, that's the National Air Quality Database in Austria, that's been sitting in the basement of our agency for decades, collecting all of the data. So we said, okay, this is our source, what do we do with this? For first step, we said, okay, for the feature service, we decided to use GeoServer. And since the national database structure is too different from the Inspire model, we said, let's put an in-between database where we ETL the data from the national database into this dedicated Inspire database, and then link that with GeoServer because it's much saner for performance purposes. And that's where we've got our feature service. So that covers these parts of the data flows. Okay, there we've got the structured in accordance, blah, blah, I already told you that. And we've got various stored procedures to do all of the ETL processes, so that went quite nicely. Configured the mapping in GeoServer. Feature service was running nicely. Then we had the next step of adding the sensor observation service. And to give you an overview, that's now providing both the primary and various aggregates. But if you look, there's a little overlap between the two braces there. And the tricky bit we ran into is that you have some bits which actually go into both. Go into a bit more detail a little bit later on this. Back to our implementation, we looked at the existing SOS implementations, and most of them were also, again, expecting a dedicated database under them, which for the station metadata we have no problem with because it is fairly static. But the real-time data coming in to then have to pass that on to the next database, we thought, no, we would like to have this directly attached to the National Archives, reading it as it comes in. And so for this purpose, we got in touch with the Austrian Institute of Technology, who on the one side did the basic air quality database 20 years ago. At the same time, they've been very active in the various SOS prototypes. And so they actually did a new implementation based on their further development. You see the word UVEDAT twice. That's basically Environmental Information Data System, German acronym. The old database is normally UVEDAT. The new version they have is Open UVEDAT, and they've now added a new version of the Open UVEDAT which can do SOS. And the cool thing, I mean, you need to be a geek to configure this because it's not configured. You have a data handler class. This is written in Java. You have to encode a simple set of setter methods, open-close methods, filter methods. But the cool thing is you can basically dock this onto anything you can access with Java. You can put it on a database, you can put it on a file, I mean, you can have a CSV file behind it. If you can get it with Java, you're there. Okay, so we had that nicely done. And then we got back to this overlapping bit of saying, what do we do with this little bit in between, which actually gets served from both servers? And I mean, in reality, it's the feature of interest. What am I measuring on? This is something which I need this from the spatial level, describing the station. I need it from the measurement side, describing what am I measuring on. The second point, which is also in the overlap, is the process description. How am I measuring? This is relevant station metadata. If I'm looking for air quality stations across Europe, I want to know what are they measuring, how are they measuring, what is the process used to measure it. And at the same time, this is integral information on the measurement itself. So these are the two bits which in our architecture would now have been stored in two different systems, and the feature service part doesn't get updated as often, and this would start to diverge. And this worried me. And so after banging our heads together for a while, me and the technicians from AIT, we actually came up with a very nice, it's almost a cheat. We realized that the data being served by the feature service, the only difference between the output is the wrapper, your feature collection. If you've got it from the feature service, you've got an WFS feature collection. If you have an SOS, you have an SOS observation collection. I forget what the exact term is right now. Everything else is the same. So we did a little workaround that the SOS for the primary data, for the get observation, it goes directly to the archive via the data handler class. For the information on the spatial feature being measured on and for the measurement methodology, it changes the request to a feature service request, queries its coupled feature service, gets the response back, rewraps that the way the SOS user would expect it, and provides it out. And this solves any problems of having redundancies in there. Nicely covered the overlaps. Here we have the service URI, so if anybody wants to start playing with this, it's available, it's online, it's running. Conclusions of this: GeoServer is, from our experience, quite well suited for the provision of Inspire data. However, it's not easy to configure, although, I mean, Hail has been making this a lot easier. The problem was the nice Hail extension didn't exist when we were doing this. Client side is going to be a problem because now we have all these nice complex features online and there's basically nobody out there who can consume them, but that's going to be all of our problems the next years. The lightweight SOS from AIT is nice because you can configure it to whatever you have out there, and you do need to build a program, but it's fairly simple to do. The redirect of the overlapping requests keeps things nice and synchronized, aligned. And we've also been considering options of could one actually take the solution, since it's fairly generic. The only thing which would have to be customized to a different data source would be the data handler to get access to the archive and the mapping into the feature service database. The rest is totally generic, could be reused by anybody. Thank you for your attention.
Thank you, Kathy. So our last speaker today is again Dominique Laurent, and she's presenting now the challenges implementing INSPIRE coverage data.
Yes, can you? Yes. Thanks. So, once again, I will explain first the context. So, the context is that we had an initial workshop in Barcelona that was organized by INSPIRE, that is the Knowledge Exchange Network from Eurogeographic, and by the INSPIRE Thematic Cluster 3 on reference system, geographical grid, ortho-image, and elevation with Jordi. And the objective were to share our experience about implementing coverage data and services with focus on themes, elevation, and ortho-image. The agenda of this workshop, we had a training session with Alex Dimitriou from Jacom University. We had a session about national experience transforming elevation and ortho-image. And we had a session about web coverage service experience with other communities, for instance, oceanography and meteo, and we had a discussion on open issues. So you can see the photo of the people attending the workshop. Maybe some are here in this room. We had some following activities, such as a webinar to go closer into the question. We tried to have also a list of open issues to capture our understanding about the issues, and it was not so easy. And the main information is that all the documents, the videos, the minutes of this workshop are available on the public page of Eurogeographic. So everyone can consult them if you are interested. And we decided to have also follow-up activities during this INSPIRE conference. So there is a two-day presentation. I am not a coverage expert. I was just organizing the workshop. So I will try to explain in simple words what I have understood or what I think I have understood and the open issues that are remaining. And for those who really want accurate, guaranteed, detailed information, please go to tomorrow morning to the workshop with real specialists such as Jordi and Peter if you want really to get very detailed and very accurate information. So, what are the main learnings from this workshop and from the following activities? I think my color coding is rather simple to understand. What is green is good, what is red is bad, and what is yellow is in the middle. So what is in the middle is that from the agenda, not even going to the discussion, it was very difficult to set up the agenda because generally we make this workshop just between NMCAs, but for coverage services, for coverage it was not possible because NMCA we have a limited knowledge about these coverage topics and we didn't have enough knowledge. So our knowledge is not zero, we have some, but not enough for a whole workshop. So we had to ask the help of other communities, and it's good news is that other communities have more knowledge and they may help. typically, the Jacobs University help a lot with the training session, and we had also the meteorologic and the oceanographic communities that are quite more advanced than NMCAs in coverage topic. Some learning also from the exercise of making a list of common issues. It was very difficult to agree on this list of common issues because we had different formulation, we were not using the same terminology. So really getting this common understanding about just how to formulate the question before finding the solution is quite difficult, and especially for coverage dummies such as I. But it's visible. The knowledge is progressing if you make efforts. Something that was quite interesting from the training session, it was to understand the power of web coverage services. These web coverage services are, I will say at least in theory, very powerful tools to deliver and better harmonize the data expected by InSpy. As Peter, I explained in the previous presentation, there are a lot of functionalities in these web coverage services, such as extraction, format conversion, coordinate reference system conversion, resampling, these kind of things. So we have really these wonderful tools that may help us to deliver coverage data. We had also some learnings from transformation experience on ortho image and elevation. A very common issue is how to deal with huge volume of coverage data. And for data producer, we have to decide on the approach to provide coverage on a vast territory in a way that is digestible by the download services. I will give some illustration. So on the server side, generally we have big data. For instance, for large-scale orthoimagery, we may have terabytes of data to have the whole country. On the client side, we have the user, and the user may want maybe a small area, maybe a bigger one, we don't know in advance. And between both, we have the internet pipe that is rather small. So what is the issue? The issue is how can we organize our data, how can we cut this big data set into smaller pieces that may be digestible by the internet pipe. Of course, it depends on the choice of download services. What I understood from the workshop, it really depends. If we are using the predefined data sets, we have to make small coverage. For instance, to use tiles or municipality. Maybe there are other solutions at encoding level, but I say it will be for tomorrow morning to know more about it. If we use the web coverage service, we don't have to cut the coverage into tiles. The server can handle it. But there are some doubt about what the client may do or not. Is it really able to receive anything? Once again, it's an open question. And if you want to know more, come tomorrow morning, once again. Something also that was interesting, it was from the web coverage service presentation. It allows, at least me, to get a better understanding of what is the work going on the MIG Working Group 7. The standards is proposing various functionalities. Some are mandatory, some are optional. So the work of the working group is to decide of the functionalities to be included in the implementing rules about web coverage service. And it was also to check if implementation solution, if there are tools to handle this web coverage service. Some, I will say, personal learnings that engage only myself. Maybe some of you won't agree. It's a practical conclusion. What to do when going back home? InSpy is to provide better data harmonization. So how does it work in my understanding? We have this coverage model that is, I will say, rather complex for those who are not accustomed to it. if we look at the InSpy coverage itself, in fact, what we find is some coverage touch. It's some kind of metadata about the coverage that has to be provided in GML coverage. And the true data, in fact, you don't find it in this key model, but it's hidden in the mother feature type. It's the range set. And the range set, for instance, it's the TIFF image for auto-imagery, or if the matrix of value for elevation. And generally, it has to be provided in image format. There are other solutions possible, but I think it's the recommended one. So now, when we make our transformation for InSpy, what are the steps? In my understanding, there are 3 steps. We have to provide this coverage touch by filling the InSpy coverage model, by filling the attributes that are in the coverage feature type. We have to harmonize the data to be done in the range set. However, the InSpy coverage specifications are quite flexible. For instance, there are no constraints on the grid size. Several coordinate reference systems are possible. It's not illogical because InSpy is about harmonizing existing data. We cannot change everything. And we have to set up the download service. So how is it going to work with the 2 options? With the first option, with predefined dataset, let us imagine a cross-border user. He will make requests, but as it's predefined dataset, there are not he cannot really ask for parameters, so he will get what is available. It's not sure that this coverage touch will really be useful in case of predefined dataset. I'm not sure. I have doubt about this. And of course, requiring the predefined dataset, as there are various options in InSpy, very likely the user will receive heterogeneous data and not really harmonized one. If we go to the second option, that is option 2, with web coverage service, what is going to happen? We have still our user, but as it's web coverage service, likely the user can put some parameters in his request or her request. The download service will likely, as it's a web coverage service, use the coverage touch. This metadata will be likely used by the web coverage service, so it will be useful. And as the web coverage service can make some operation, it may harmonize data according to the user request. So likely, our user will get harmonized data and harmonized data according to the parameters he or she wants. It's my understanding of what web coverage service can do. So what was the practical conclusion about this is that, in my understanding, InSpy coverage data specification bring real value to users, but if we use the web coverage service. So the advice I brought to IGN is we should use web coverage service and not predefined dataset. However, after the workshop, there was some legal uncertainty because the implementing rule about web coverage download service was not yet ready. There may be changes also in the standard about GML coverage. So my conclusion was we should wait. The deadline for elevation on auto image is only in 2020. So let us wait. And I must confess that it's something we are very happy to do regarding InSpy topic. In practice, we were not relaxing in an armchair, but make a lot of work about national topics. But nevertheless, we were quite happy to wait. But maybe now the situation is improving. We will get implementing rules for this web coverage service, and I will come myself to the workshop tomorrow to know more about it. And if it's this case, maybe we will move from the relaxing armchair to the starting blocks in order to get this inspired target related to elevation and orthoimagery. So thanks for your attention.
Thank you, Dominique. So this is the beginning of the questions and answer session. So if you have any direct question for any of or some of the speakers in the room, please.
Hi, my name is Michal Mehd. I'm from Czech Technical University in Prague, and I have a question on you from Francois. Have you considering the third option that you are using predefined data, but publishing it using some surveys? It's also possible.
Not at all, because I was not aware of it.
So if I got your question right, you see predefined data sets as a special case of the service. Right, exactly my opinion. That is just something that maybe has been introduced because it's really just a simple Apache web server to implement it. But WCS allows you any kind of subsetting, in particular, getting anything that might be predefined or so. So we don't need that restriction, in my personal opinion.
I don't disagree with web coverage services. I haven't studied it yet, and it looks really interesting. But I only think that this third option may be easier, maybe for someone who doesn't have enough experience or this kind of, you know.
And actually, there are implementations out there. So pretty much all the well-known suspects support it already. So actually, in my humble opinion, this would simplify things. You just take any of the existing packages, implement it, and deal done. Whether it's fixed, predefined, or variable, you don't need to differentiate any longer.
Any other question?
Hi, this is Teresa from the University of Leicester. I'm interested in Kathy's talk. It was very interesting. Isn't the data sets that local authorities have to provide as a regulatory functions to the government? How do you see the new data sets conform the WCS and the new, I'm not too familiar basically with the INSPIRE directives, but I'm quite familiar with what the local authorities provide as a data set, and they have to provide the limitations on different contaminants. So how do you see those data sets being merged to the new standards? I see it's going to be a problematic in order to get local authorities provide that information in the way that is standardized, basically.
Okay, I mean, there's another talk I did a few years ago, which was how the European reporting standards were developed. And these have been developed based on INSPIRE. So if you are reporting to the European Environment Agency, that's the level I was talking about. This wasn't the regional offices providing it to the national level. It's what all the member states and also the various partner countries to the EEA are providing on a regular basis to the European level. And there the reporting standards are already INSPIRE based. So that's the same thing. And that's also the reason we did that was that actually if you have your reporting data online, your INSPIRE requirements are covered because the reporting is INSPIRE plus the addition for reporting. So that's taken care of.
question here.
Hello, I have the question to Torsten about this degree. I'm Sulev Õitspuu from Estonian Land Board. Is kind of success stories already, where is Annex 1 data sets already harmonized and available through this degree software, like addresses linked to the cadastral parcels and so on, which covering full country, or?
So the data we got so far were from environmental agency, so different topic or different data theme. So what the users gave us were data which then end up in protected sites, for example. A similar success story for the data themes you just mentioned, I cannot provide right now. We know that degree download services are used for that, but I would like to know if there are data providers out there who are exactly doing that, because even we as an open source project, we don't know who is actually using degree. I get in thank you. Oh, may I take that opportunity? So who is actually using degree? Well, I do, daily base. Thank you. Okay, so there are some, and I think it would be nice, and I think that's nothing about degree and open source software. I think in general, the OSGeo projects, perhaps some of you might know that we had the OSGeo World Conference, the FOSS4G in Bonn recently. I think every open source project, the OSGeo projects, which do provide tools, software for Inspire, love to get that feedback. How do you implement Inspire with our tools, our software? And I really do appreciate the activities from JRC, Inspire in Practice, where I think there hopefully a database evolves where implementations of Inspire and tools are linked together. And then I would be hopefully then better to answer your question. Okay, yeah, thank you.
Any other question? So I have some. Okay. Question for Dominique. I think that all the whole activity of the EARTH project, which is delivering examples of services and, for example, these SLD examples, could be also interesting for other providers. Are they available anywhere in platform or something that could be distributed?
I think yes. I don't know exactly where, but they are part of the specifications, they are part of the deliverables. So if not yet, they will be available they are deliverables of the project. Mm-hmm. So they should probably be available to everyone. And they can be used, or at least consulted.
Okay, thank you. And the question for Peter. Yes, you. So at the moment, the data specifications dealing with coverage data are linked to somehow a fixed way of delivering the Inspire coverages. So, for example, the GML-COV standard, for example. And from your presentation and also from comment from the audience, there are several other formats that could be used to deliver and get this information from a WCS standard, for example. Do you think that if we open floor in the Inspire environment to use these additional formats as an option for interchange, this could be a problem for interoperability? I mean, for example, different data providers distributing the coverage information in different formats. So what's your opinion on that?
So do you realize now the hard part has started? Now that Jordi is asking questions. So the coverage model attempts to build a stable platform on which you can have different representations and encodings. But each of them can be transposed, can be translated into another one. And so whatever you use, you will always get something that is comparable. Therefore, actually, excuse me, I believe that not restricting formats is not a problem. We had so many discussions also in OGC, iterating over and over, because we want one standard format. That was always the claim. We could try. Who opts for having GeoTIFF as the overarching format for all data? 1, 2. Who opts for having NetCDF as the overarching format? 2, 3, and it seems different people. So could you please go out and get an agreement and come back so that we have one? You see, that's the issue. We won't find a particular format. And therefore, having several ones, I believe, is not the issue once we have stable definitions. And that exists or is in progress. For example, GRIP2 is the latest one that has entered the OGC pipeline. May I add something about the CRS issue? That is something where we might say, for example, that everything is provided in one, say, ETRS 89, as the base that anyway institutions, agencies should have or do have already, because then we have the CRS facility, this extension that allows you to reproject in any system that is meaningful, and so you can get any extra as an add-on. And then actually agencies might decide to not offer the CRS extension because it's too complicated, too computationally intensive, whatever, but they have a fallback ETRS 89, which might be good for Europe. But that's my personal belief, and I'm ready to get educated if I missed something.
Okay, thank you. So if there are no any additional questions, I would be closing the session, and I want to thank you very much to all our speakers. Okay? it's not a question for me?
You're squeezing us. You have been squeezing us with questions. May I ask back? So we have some issue, like for example, the thinking about coverage version 1.0 versus 1.1. What are the plans of MIG-T in general for addressing these and coming to answers?
So you mean about the different versions of standardization?
For example, in general, the questions that Dominique has collected and other questions that are open. So what is the idea, how to progress with resolving those?
Okay. So I think that at the moment there is no action in the MIG-T in order to, for example, take into account the new version of the coverage standard or things like that. But I think this is something that it's more on our shoulders. So if we think that, for example, we should be opening the floor for new standards, for those standards that are newly appearing now. So it's our job, for example, through the thematic clusters, elevate this issue or elevate this request to the MIG-T in order to decide. So then member states the member state representatives in MIG-T may discuss it and approve a solution of that. So
obviously we have some work on our plate then. Okay. Thank you.
And just as a comment for this, I would be willing of all of you to consider to show your implementation experiences. If you have any improvements, any achievements regarding implementation of web services of any kind related to INSPIRE. So there is an open platform, which is the thematic clusters. Different thematic clusters covering different areas, so please use this platform in order to share your knowledge, your doubts, and best practices. So thank you very much.